All right, what's up, ladies and gentlemen, to another open live Q&A. My name is Mr. McLogan, and in this live stream, I want to be able to answer your questions, as well as I have a nice, good docket of some math questions that you guys have submitted over to me. So I'm excited to dive into some of those questions, and also for some questions I don't get to, or even some questions I do get on this live stream. I will be putting them up on my main channel, or at least trying to make some videos of some ones that I think are interesting here enough. So if you do have a math question, then feel free to go to brianmclogan.com/Q&A. If you just have a comment or just a general question around math or a current situation you're going on, some dating advice, then feel free to put those down into the chat and I can go ahead and pull that up. Where is my thing? There we go. All right, now I got everything back in front. And Unknown, good to have you on. I have a math exam tomorrow. The chapter is circles. Tell me some important tips for ninth grade. Well, I would say if there's one thing that I'm assuming you're doing circles like in geometry, know all those formulas. And I know sometimes it can be very, very difficult to remember them. So maybe get some flashcards or maybe make sure you write them all down on a single sheet of paper and just review them, because a lot of times students will think the problem is really hard, and it's really just because they don't have the right tools to be able to solve the problem. And the tools are going to be those circle theorems. So make sure you have them down, make sure you know how to apply them. And that just comes into, with some repetition and some practice. And I think you're going to do all right. So best of luck. RF, I looked at that trigonometric identities problem and man, that was a doozy. I've worked at it. Actually, I think I have, where is it? I worked on it both sides. Yeah. You can see, like, look it, I'm a math nerd. I spent like quite a bit of time trying to figure out some solutions on that one. And no matter which method I tried, I kept on going back to the exact same thing. So I worked on the left-hand side. I'm not sure if maybe working on the right-hand side would be a little bit easier, but I'll kind of wait. I'll maybe give that one a shot, but I'm going to have to table that one. So sorry thank you for joining in, but I'm not going to be able to get to that one. I'm on here. It's a good question. So thank you for submitting that one. I don't know, there's something I got to break through on that. And I haven't worked on the right-hand side, so maybe I'll go. I was thinking the left-hand side would be best. I tried, difference of two cubes. I tried using Pythagorean identities. But either way, they both gave me the exact same thing. So not sure what I'm missing, but yeah, I'll maybe go and take a look at the right-hand side, see what I can do. Hey, AJJI, how are you? Hello, Ms. McLogan. May I ask a question about a specific problem? Lilybeth, you may. Unfortunately, though, it's hard for me to be able to get all of the questions onto the live stream. So my best recommendation is I have made a commitment to be live each and every Sunday. Obviously, I'm sorry, guys. Sometimes life is going to take in. My daughters are with my wife right now. So I was like, all right, time to go live, right? And sometimes I go live at 12, sometimes at 7. Next week is the Super Bowl. So I don't even know if I'll be able to go live that week. But my best recommendation would be to submit a problem at brianmclogan.com/Q&A. Just don't plan on having a test the next day and hoping that I'll have enough time to go over each and every question, because the reality is even the questions that get submitted, I just can't do every single problem that people get. Some problems I do, some problems I haven't seen before, and I work through them. Like I said, with RF's problem, it's probably spent 15, 20 minutes going through it, trying to go through it. And again, I have to do that to make sure that I can provide an explanation, right? It's a little bit different than just doing a math problem. But when I want to do a math problem for somebody else, I want to make sure that I can explain it properly the way that you need to go and do it, just kind of like a teacher. And even when I'm teaching, I wouldn't just show up and just start doing math problems. You have to plan and prep and give and make sure you have everything kind of aligned. So therefore you are ready to explain it in a proper way. And obviously some problems are going to be easier than others, but the difficulty is when you get such a variety of questions, it's sometimes difficult to be able to have a great explanation right off the bat. So that's why I like to have a little time just to prep the questions for these live streams. because I've winged them before, and either I make a mistake, either I forget it, or my explanation is not that great. And it's like, well, yeah, you got the answer, but it's like, you could have just also typed it into Google and gotten the same answer, right? So I want to make sure I can provide you guys with some value, and that takes in a little bit of work on my end. That Daddy, we're actually going to be doing some synthetic division in this video. I think it's actually the first problem I'm going to do. So stay long. I'll be getting into some math problems for you as well on that. Oh, wow, that looks like that. Why is that so big? There you go. So yeah, I'll get to some math questions that. Ooh, hypothetical. All right, let's give this one a shot. Can I ask a hypothetical? Let's say someone hasn't been in high school. They dropped out in grade 8. Do you think it'll be easy for them to catch up starting in grade 11th? I would say, since this is a hypothetical, it's all dependent on the person. I would think for the majority of people, no. But I wouldn't discount anybody's ability to be able to put in the work or to have the understanding to catch up or to be able to have that as a seamless transition. That's kind of like saying, would it be okay just to skip high school and go right into college? Well, no, I don't think so. I mean, there's a lot of content that you have through high school. Also, there's a lot of maturity and development you go through in high school. And then to go into college, that's like a completely different beast. However, are there people that can do that and or have done that? Of course. So I'd say for the majority, no, I don't think that's a great idea. I don't even like advising students to take advanced courses or courses over the summer, just because the majority of students, I don't think that is a great idea. However, a lot of people and a lot of situations are completely different, and that might be a great route for some. I do have light bulbs in my house, and yeah, I actually have some really bright lights over there. I used to do some videos with the bright lights, but yeah, my head was so shiny, it was kind of all right. Awesome. Well, if you don't mind me being a little bit of math nerdy, if you take a picture and submit that over, I'd greatly appreciate to see how you approached it. Speech team alongside Ismail. Hey, Miss McLogan, I've watched your videos for a good time now. What is the last unit of Algebra 1 before you enter Algebra 2? Thanks. That's a great question. I don't know. It's been a long time since I taught Algebra 2. Or sorry, Algebra 1. So I would just maybe look into a table of contents. I mean, any book or any curriculum is going to vary from on there. I think if I remember correctly, one of the last things we got to was like polynomials and radical functions. But I could be wrong on that. So, everything is going to vary from on there. But, I would just maybe look into some different texts that's available online for free and kind of um, see what matches up and see what would work for you. Thank you. I've learned how to solve 3 equations with 3 variables from you. Awesome. Without remembering any formula. Thank you. You are very, very welcome. I'm so happy to help you out. Anan, sometimes you state just by looking at a quadratic equation that is not factorable. How can we tell that a quadratic is not factorable just by looking at it? So that's a great question. So the way that this kind of gets into a little bit of a mathiness, but it comes into doing a lot of like work on your head. And I will table this problem. Let me see. I can star this. I will probably try to do, since you're not submitting a question, but it's a general one. Why can't I type that in there? I had this. Huh. All right. Either way, I'll need some little explanation on that from on there. But yeah, it just comes into doing the math in your head from there. So I'll try to remember to come back to this problem. And there you go. I'll see if I can go for it. How do you find the limit of a function if it's in the right or the left? Just this. Well, so you got to understand the left-hand behavior and the right-hand behavior. It's helpful to have like a specific problem that you're referring to. But usually, typically, it's really helpful to know what the graph is going to look like. And even though you can evaluate the general limit, the left-hand limit, and the right-hand limit without knowing the graph, but when you need to understand when you have discontinuities or when you have ending points, that's where it's helpful to know what the left and right-hand behavior are doing at that particular point. So I would recommend having an idea of what the graph of your function is looking like. So therefore you can understand what is happening at that point, so you can determine the left and right hand behavior. I am not continuing to teach anymore. I am just teaching on YouTube. Can I type a math equation question in geometric and arithmetic sequence? Yeah, go to brianmclogan.com/Q&A. That would be the best for me to be able to address it. You just want to say your old videos helpful. Well, awesome. Well, thank you so much. Happy to help. Would you say Algebra 2 or pre-calculus is more difficult? I would say, from my experience, I taught both. I would say that pre-calculus was more difficult. And here's the reason being, because this might not be the absolute truth for your circumstance or for your school. The reason why Algebra 2 in my scenario was easier than pre-calculus was because Algebra 2 is really much more of a broad class. I think you had to like pass the class to like graduate. So it was much more taught as like a general course, for like kind of everybody. Whereas the pre-calculus course was not as taught as a general course. It was basically as kind of one to prepare students for upper level mathematics. And so students had some further demands on them. It was taught as with a little bit more rigor than our Algebra 2 courses. And also, I think just the content of Algebra 2, how it kind of very much repeats and builds upon itself. And pre-calculus does that as well. But I think the difference is with Algebra 2, you could, whatever we were learning, like it kind of came back to itself. And I guess the best way I can kind of explain this in simplistic terms is like basically whatever we would explain or teach, the problems, the numbers, whatever would be kind of like changed around. And then it was like, you could do it and you do it. There wasn't a lot of like in depth of like, you have to show your understanding multiple different ways. Whereas in pre-calculus, I'd basically teach a concept and then it's like, all right, your problems for your homework are 10 different functions that are similar to what I taught that we never went over. But if you understand what we went over, then you have to now apply it. And so it's much more of that like having students apply what they're learning and showing that they learned this stuff rather than just like regurgitating what has been taught. And that was kind of how the Algebra 2 differed from the pre-calculus. I'm not sure if that makes sense, but hopefully it does. Any recommendations for first-year high school math teachers? Have fun. Enjoy it. I love teaching. I really did. I did 14 years inside the classroom. I knew it was my time to leave, and that's a personal decision. But we need great math teachers, and we need people that are there for the students and that enjoy the learning process. And I think that's the thing I miss most about teaching and being inside the classroom is not only just the relationship with the students, but their relationship to their learning and being there to support them from the beginning all the way through the end and seeing that transformation. And throughout my 14 years, when I would get down or the job felt redundant or I had tough times, I always reminded myself, what is something I can do to make this lesson better? What can I do to make this come alive? How can I make this lesson to reach more and more students? And that really fueled me to continually get better at teaching and not worry about the district policy that's changing 20 times or the issues I'm having with the kids or the parents or other teachers. I just focused on becoming a better teacher and teaching something better and better each and every year. Right. So I think if you can just, focus on improving yourself as a teacher, and focus on being there for the students and motivating and encouraging them and getting the best out of them, you have a life ahead of you of just reaping the rewards of being a teacher. And I hope it makes a long career for you. How do you prepare for F9R unit exams? I'm not sure what those are, but the way that I tell my students to prepare for exams is create basically a cheat sheet, all the formulas, all the major problems from your notes, your homework, your tests, your quizzes, put them on one single sheet of paper. We call that the cheat sheet, and constantly be reviewing that, constantly be studying that. Don't just feel like since you learned something, that's the only time that you need to remember it. You should constantly be doing spiral review, constantly be going back to older units and reviewing problems that you've gone over from there. Yes, that would be greatly appreciated. Thank you. Hello. My favorite color is not spam, so don't do that. But I would say, to be specific, because it seems like you stopped. Um, my favorite color, what I used to call that? I used to call it ice blue. That's it. Yeah, that was actually the color of my first car, and so I don't know. I always just kind of like the ice blue from on there, so I'll give that as my thing. Would you recommend? Would you recommend taking Calculus 1 and linear algebra at the same time in college? No, I would not. And again, I'm not the person to ask this question. This comes into your professor. This comes into your parents and your guidance counselor. I think just, in my opinion, linear algebra was such a, I wouldn't say a struggle, but it required more attention from me than my calculus series. And so, not to say that that might be the same case for you, because everybody's going to be different. Every university is going to have, different dynamics in that regard. But for me, it wouldn't have been a good idea to do that. I had to put in a lot of effort into my linear algebra course, and having that foundation from calculus into linear algebra was super helpful. So if I was learning calculus at the same time, I just don't think I think I would have struggled immensely. Now, like content wise, is that something you could get away with? Yes, you could. I just think the demands of the courses to really in depthly understand and do well, taking them at the same time would be difficult in my opinion. But seek out other advice, please. Well, awesome. Congratulations. I love that. And well, awesome. Congratulations. I love that. And kudos to you for, going back and making sure you get your education. I love that. What are your tips for a student going into calculus in high school? Are there lots of topics from advanced functions in calculus? Um, I think advanced functions is very similar to the pre-calculus. So yes, there is, but calculus is its own beast. So, everything from advanced functions, everything from pre-calculus is all there to prepare you for calculus. And, one of the most difficult things for people in calculus is not having that strongest foundation. So I think that's really, really important to have a strong foundation from your advanced functions course from pre-calculus. But even if you have a little bit of a weak foundation, you can catch up in calculus. So don't feel like it's an end all be all from on there. And that's the important thing I'd say for you to focus on is calculus, especially in high school, could sometimes feel like it's going fast, right? It's going to demand that you know some of the stuff from advanced functions. So if you get stuck, if you start to feel confused, you start to feel overwhelmed, make sure you seek out help. Do not just like crawl up into your desk and say, I'm not going to try or I'm not going to do work. Do all the work that you are assigned. Make sure you always are asking questions. And it can be a roller coaster throughout the year. Sometimes units are going to be tough. Then you might feel some confidence, but continue doing in the work, continue asking questions. That's my best advice. Mr. McLogan, what I meant to state is, isn't every quadratic is factorable by using completing the square quadratic formula? Yes, that is correct. Or is there some quadratic equation which is simply not factorable? No, everything is going to be factorable across real, rational, irrational, and imaginary solutions. So yes, everything can be. When I refer to something as non-factorable, I'm referring to factorial costs, rational, well, not even integer factors from on there. So that's usually what I'm looking is if it's factorable, that means I'm going to have I can use integers to factor it, not fractions um, or irrational numbers or even imaginary numbers. But yes, every function you can or every quadratic you can be able to rewrite in factored form. And yes, that would come in from completing the square or using the quadratic formula. Hey, Kara, how do I get through math when I am sleepy? That's a great question. So I probably haven't said this on the live stream, but when I took econ in high school, I had a teacher that he literally had the most calming voice ever. And I really, really liked econ, but I was just so tired. So I literally slept in class throughout the whole year. And I enjoyed the stuff. So I could learn it, and I would just listen to them as I closed my eyes. And I didn't do great. I think I got like a C, or maybe even a B on some semesters. But I really enjoyed the class. I loved them. I was just a rude student, and I was just tired. Like I couldn't get everything over it. But so you might have that case, or you might have that teacher where it just kind of like wants to put you to sleep, whatever else. Or you just need to look into, the dynamics. I mean, obviously, look into what you're doing, working out, eating properly, and sometimes when I get really, really tired during the day, I'm assuming that's maybe when you have your class, it's because either I just ate a lot and I just get really like that midday, thing. So, maybe you can look into those kind of things. And then or also if I, stayed up too late and didn't get into my good routine. So I'm not sure what may be your case, but maybe just do some diagnostics and kind of see. And also maybe the case too, like maybe you do have a teacher that really just puts you to sleep, and you need to pay attention, because I could never sleep in a math class. Like econ, I was able to get by. Math, I would be completely lost. So maybe see if it's something you can like stand up and sit in the back of the room or something like that, move around. I always allowed students, when they would sleep in my class, go and get a drink of water. Like get up, get moving, go and get a drink of water, come back. Right. Um, because I get it. We all go through times where we're going to be sleepy, but yeah, to get the best out of your course, you're not going to want to sleep for it for obvious reasons. Go ahead and submit it to brianmclogan.com/Q&A. Difference in applied and pure math at university. Every university is going to have a different route. I look into the courses that you're going to be taking, but obviously when you're looking at applied math, they're going to have courses that are going to be, taking that mathematics and obviously applying, doing something with it. And pure math, I would say, is a lot more of like this discovery of those, those math concepts. And so I'm much more of a pure math fan than applied mathematics. But, look at the course structure, see what's going to be most relevant for what you want, and also what appeals to you the most. Yes, it's just been a long time. So it's once I really get through my calculus, I'll see if I can. But I do have already videos on implicit on my channel. If you just want to go to the channel, if you look down at the playlist, you'll see I have a whole playlist on implicit differentiation. Do you have any tips on solving inverse cosine without memorizing the unit circle? Because I'm pretty sure the inverse of a negative cosine has two answers, but the only one works due to restriction. Yes, that is correct. So the inverse cosine is going to have two solutions in the second quadrant or in the third quadrant. However, based on the restrictions of the cosine inverse, we're only going to look for the angle that could be in the first or the second quadrant. So when you have that negative value, it could only be the angle from the second quadrant, right? Because otherwise then it wouldn't be a function. So you have to only have one answer. I was born in the United States. Oh, but when I was making that mistake, I started to realize how I got it normally wrong. Is this the same question? Oh, when I don't know. You're going to have to submit this question to me so I can go and take a look at it. Hey, Brian. Lately, I've been in pre-calculus, and I've recently was tutoring other people on a group session and was helping a good amount. Is this beneficial for me as well if I keep tutoring people? Absolutely. That is incredibly important, to be able to take what you are learning and teach it to other people. I've made a couple videos on this, to how, like, that's advice that I give students, like how get better at math. Teach the math, right? Like I got an A in pre-calculus when I went to college. I got a D in high school, and then I went to college and I got an A. I thought I knew pre-calculus, right? So when I became a teacher, a couple of years later, 3 or 4 years later, I'm now a teacher. Oh, it was probably like 5 years later. Actually, it was probably like 6 years later, because my first couple of years teaching, I did teach pre-calculus. But then eventually I went to go and teach pre-calculus, and I'm like, oh, I remember this stuff. I got an A on it. Like I remember all this stuff. I'm good at it. And boy, was I wrong. I learned so much that first year, because I had to, not only, it's not just doing the problems, but being able to explain it to students was an extreme struggle for me. You know, I hadn't taken it in 6 years. Even though I remembered how to do the problems, I didn't have a very strong foundation of what exactly I was doing, why I was doing it. And as a teacher, that's what it's all about, right? So the process of me going through the problems and being able to teach it and being able to make connections to help the people that I was teaching allowed me to have a much, much deeper understanding of what we were doing. And so by you being able to go through what you understand and explaining the process to other people is the exact same thing that I did. And it will help you tremendously in not only your own understanding, but your ability to communicate to people about what the math is about. Um, Hey, sir, how do you tackle mathematics multiple choice exam? I find it hard to pick answers. Yeah. So I always tell students whenever you're going through a multiple choice exam, do the easy problems first, right? So even if there's 5 problems that you know how to do, just do the ones you are most confident on, tackle those first. So don't do 1, 2, 3, 4, 5. Go through, find the easiest problems that you can do those first. Then do the ones that you know how to do, but they're maybe a little bit more tricky. Maybe they involve a little bit more thinking or a little bit more, algebra to complete. Do those. And then at the end of the exam, do the problems that are the most difficult, do the ones that are confusing, that require the most amount of work. And I feel like that not only kind of ramps you up and kind of builds you up in your brain as far as being able to, do all those computations. And then it also just leaves, if you are struggling with some of those problems at the end, those are the most difficult problems that, you might have were most likely to get wrong compared to the ones you did first. So that's what I always tell students to do for multiple choice exams when that's possible. I'm currently doing Calculus 1 and I'm very confused. I don't know if it's just my teacher because it feels he's just, I don't know. It could be the case. I would just recommend what helped me the best when I was in Calculus is finding a study group, finding a study partner, just somebody that you can do your homework with, that you can study with tests. It just made doing calculus so much more better. We did Calc 1 and Calc 2 together, and he was definitely a part of my success and being able to do well in those courses. Just because when I didn't understand something, we could talk about it. And then, I still went to the professor, still did offsite. I still did my own studying, but it was just so nice to have somebody to do things with. And then I realized yeah, the teacher is there, but I'm the one that owns my ability to understand this information or not. So, I'm going to take responsibility for that. And I'm going to work with this person to make sure I can do the best I can, even regardless of who my teacher is going to be. Awesome. Happy to have you on. Hi, Brian. I got A-level math exam upcoming in May. I hate doing mechanics and stats. I'm just not great at it. How do I overcome this fear? Put in the work. Somebody asked another question. They submitted to me and it's I can't remember what it was, but it's how do I prepare for this? I'm like, practice. You got to put in the work. Math is a lot of times, guys, it's not sexy. It's not fun. It's not encouraging to go through this. But it separates people because a lot of times that hard thing where you're going to get the most out of it is difficult to do. And people sometimes don't want to do it, but you have this exam coming up. It needs to get done. You're enrolled in these courses. You've paid for the courses and you have this exam coming up. And guess what? Once you're done with this exam and you do well, you don't have to go through that over again. Now, obviously on you taking, mechanics and the stats, I mean, I don't know where the courses of your studying, and maybe you need to rethink that. If you don't like having to take these courses and you're going to have more of them, that's a different answer to the question. But if this is just something you need to overcome, you got to face it head on and charge forward. Put in the work, put in the practice. And guess what? After May, you're done. What's the best studying method for high school math? I mean, I think as far as math, there's a couple things that you need to have. One, you need to be able to practice, right? So whenever you got problems right or wrong on a test, a quiz, on your homework, consistently be going over them and redoing them. Obviously, the problems you got wrong, it's important to make sure you know where you got your mistake and to practice them. don't just practice them like the night before the exam. You should be doing this like at least on a weekly basis, keeping that stuff fresh in your brain. So obviously doing math is important. I think it's also important to make sure that all of the definitions, the theorems, even the most important examples that your teacher has referenced multiple times or you covered at length, put those on a sheet of paper. And therefore, you can constantly be reviewing that sheet of paper when you're doing those practice problems each and every week. I called that the cheat sheet, and I had my students create them for every single course that we went through. I even allowed that. I even told them to do it for every single chapter. And it was just that review for them to be able to consolidate the most important information that we covered and put it on that sheet of paper. And I think that was always really, really helpful for them to have that organized of what's most important that they're learning in this course, in addition to doing the practice and getting prepared. Um, you know, calculus, guys, is always going to be relative. It's always going to be relative, if it's easy or not for other people. So your experience and your math journey is going to be different from everybody's. Your experience and your life experiences are going to be different, right? And that's what's helpful about that's what's important about the learning process is you got to connect it to something you know. And everybody's going to have a different base of what things they know, what things they understand. So keep on putting in the work, keep on asking questions, keep on going, get help. Trust me, it does get better. I know a lot of times it can be a struggle, but put in the work, ask questions, and keep on charging ahead. Okay. And I have full faith that you can improve your circumstance by doing just those things. I have not experienced DeepSeek yet. I'm actually very interested in it. I've worked with ChatGPT multiple times, and sometimes I get stuff that's good. Sometimes, a lot of times, though, probably more often than not, either I don't get an explanation that is mathematically correct, or I'll maybe get some example of problems that don't have a great variety. So I'm actually interested to look into DeepSeek and kind of see how that is different from ChatGPT, but I just haven't had the time up to yet. Uh, were you scared the first year of being a teacher? Were you afraid that you were not doing a good job and that you will screw the student up? 100%. I can't explain this feeling of your first year of a teacher. And I remember somebody explained to me, like, it doesn't matter if you go to school to become a teacher, there is nothing that can prepare you for being a teacher for the first time, right? Having that control of the classroom, having these people be in there looking for you to lead them. You cannot replace that with student teaching. You cannot replace that from being in lecture halls. There is nothing to prepare you. It is scary for sure. And it was a tough first year, but I also had some really, really good model teachers around me. And one of them I remember said something to me that stuck with me. And it was something also I told to other teachers. It's like, it's your first year. You're going to make mistakes, right? Don't hold yourself to such a high standard. Because I think as teachers, we do kind of sometimes struggle with that perfectionism. We always want to be the best at it. We always want to make sure that everybody's happy, and having a good time in our class. And she's just like, you know what? Just take it in, learn what you can, just make sure you're there, be there for the students, but just get by through the first year. Because once you can get through that first year, then you kind of get into the sophomore year, like so many things come in together and so many things are improved from that second year. But your first year, it's rough. Don't try to be the dictator with the students, dictator with the grades. You don't know what you're doing and you're not going to be perfect. So you have to have that humility. You have to kind of accept that. Just do what you need to do to kind of get by, to survive, and then wait to really start making those improvements that you want to see as a teacher in years 3, 4, and 5. What motivates? Let's see this one. What motivates you to teach math? When I was inside the classroom, I love the fact of helping students being able to see that the potential that they have within them and helping them see that through their struggles in mathematics, of them putting in the work, them listening to the advice I giving them, and them going through, seeing them put in that work, seeing them go through those struggles and seeing them be successful at the end of the year, that's what motivated me to teach math. What motivates me now to teach math is, again, I still see those students behind me on the screen searching and looking and being frustrated and struggling like I can't learn math, or believing that they are inferior, that they they don't have what it takes to be successful in mathematics. And what motivates me to continue making problems on mathematics is showing students that there is a way. They can, as long as they're willing to put in the work, as long as they're willing to ask the questions, they can be successful in mathematics. I am a testament to that. I struggled with math growing up. I put in a lot of work to earn my degree. I put in a lot of work of being a teacher, and I've solved a lot of problems. And I'm not a math savant by any measure, but I found a lot about myself going through those struggles and putting in that work. And it pains me when students feel like math is not for them, or that they cannot be successful in that. So that's why I always want to feel like, let me give you my spin when I'm teaching problems of what it was like when I didn't understand this problem, or from my perspective as a teacher working with students that either struggled or that, did not struggle, but that want a definite, or they want an explanation that, comes from a different perspective. And that's the spin that I always try to bring. I don't know. I didn't have to take Calc 3, actually. It's kind of weird. I don't know why, but I didn't have to take it. So, um, hey, sir, do you have any tips for confidence as you have tendency to do small, silly mistakes? Yeah. I still make small, silly mistakes all the time. So, I think just, as far as your confidence, the less mistakes you are, the more confident you're going to get, right? I think just what's important for me is just realizing I make mistakes when I try to do mental math. I make mistakes when I try to do things too fast and not show my work. So now what I always try to do is always just show my work. That helps me slow down. And also, if I do make a mistake, I can always quickly go back to there. But I don't know. I've thousands of math problems, and I still make, mental and silly mistakes. So I've accepted it. I don't get down on myself about that. I still feel pretty confident in my abilities when I'm doing a problem. I just realize if I'm going to rush, or I'm not going to show my work, I'm more likely to make mistakes. And so I just try to catch those as much as I can. I would say, actually, my favorite math topic, I would probably say like trigonometric identities. That is one I really do like. Are you a math nerd? I think if I have over 13,000 math tutorials on YouTube, I was a math teacher for 14 years. I don't think I can classify myself as anything else besides a math nerd. So, yes, I would say I'm a math nerd. Well, to be honest with you, I never had the opportunity to teach it. So we did have ACE in my school. There was just always teachers that were teaching it instead. So, I don't know. The opportunity just never arose for me to teach those courses. So that's why, yeah, I don't have a lot of videos on it from there. Well, awesome. So happy to be able to help your daughter out, and don't get it. Yes, advice for the SAT math. I don't have a lot of examples from this. So, there's a lot of YouTube channels and a lot of, um, supplies out there, resources for you to explore. But I would just say do as many examples as you possibly can. So get a booklet, go on the videos, or download, example things, and just practice, 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 practice. That's the best advice I can give you to prepare those tests. I can make videos on geometry. I don't know. Yeah, I think what's hard about trigonometric identities is there's no like do it this way, then do it that way. Like there's many different ways a lot of times to look at or apply using identities. So I like that approach of it. It's kind of more of like a puzzle rather than like this is what you do first, then you do this, then you do that. But for a lot of students that are used to just following directions and doing what the math teacher does, they don't like trigonometric identities because it is that ambiguous. Like, should I do this or should I do that? They don't like that. So that's why, even though a lot of students might be strong in mathematics, they struggle with trigonometric identities. I'm worried. I'm worried to do geometry because of proofs. Some of my friends and peers hated geometry because of proofs, and they're the hardest topic to cover in geometry. Even my friend who's advanced can't do a proof. I wouldn't care about what your friends say or do. Yes, proofs sometimes can be very difficult for geometry and for students to be able to complete. I think a lot of times that does come into how they are taught, how they are presented. But in reality, I don't think the proofs are like you can pass, or you should, in my opinion, be able to pass geometry without being able to be competently write a proof, right? I think having a general understanding of proof writing and how to create a proof and, generalized write a proof is good enough to get you by through a geometry course. I don't think you need to be a master of it. And I don't think that should be a determining factor if you really, really struggle in geometry or not. So I wouldn't worry about what your friends are. I would give whatever teacher that you have for geometry a open slate, but, take that knowledge into it and really realize that, when you are doing proofs, like, one of the reasons I would say that students struggle with proofs is they don't get enough examples. They don't get enough practice with it. So it might not be that it's actually that hard or their teacher can't teach. It's like they only get one or two examples, and it's difficult for them to translate that to a strong understanding when it shows up on a test or a quiz. Here's a civil and respectable question. Do you enjoy being bald? I do. I don't have to spend money going and getting my hair cut. So I've been bald since the age of 21. That's when I first started shaving my head. And yeah, I wouldn't go back to having hair and getting haircuts for anything. I mean, come on. Like, I love, the only thing that does suck about being bald is I live in Florida. I cannot go out without a hat on. I can't wear suntan lotion. I have to wear a hat. So I do hate that. That does suck because my head will get really, really red, and having a sunburn on your head is horrible. So I do miss hair for that one reason. But besides that, having a head of hair, like, I don't need shampoo. I don't need conditioner. I don't have to go and get my hair cut. I shave my head once a week and I'm good to go. So yeah, more people should shave their head. Well, go ahead and submit it. Do I like teaching? Yes, I love teaching. But I had multiple reasons why I stepped away from the classroom. And I'll just give you a simplistic answer because I've answered this multiple times, but I knew for a multitude of reasons, it was time for me to step away from the classroom. And so I did, right? I didn't want to force myself to stay inside of something that I knew my time was over. So that's why I stepped away. Yes, there is a extremely practical use of matrices. You can even go into even with our AI and be able to use. But yes, matrices are extremely practical. Awesome, thank you. Please go over limit continuity, discontinuity. Send me over a question. Go and submit it, and I'll be happy to look at it. No, I hate physics. Sorry, I just didn't have a good experience learning physics, so I'm going to stay in my lane and focus with math. Oh, thank you so much. I appreciate that. All right, guys, I am going to switch over to doing some math questions. These are math questions that were submitted at brianmclogan.com/Q&A. So if you have a question that you would like me to solve, then go to brianmclogan.com/Q&A and go ahead and submit it. If you have any other general questions, feel free to add them down into the chat. I'll try to do my best as far as getting to them, but we'll see how long this math is going to take. All right. Any advice for someone that wants to do good in math? Yeah, do the work. Ask questions. I mean, it's as simplistic as that. Practice, practice, practice. It's not fun. It's not exciting, but put in the work. And when you struggle or get questions, always, I guess some other advice would be like, find some other people that you can do it with. Math does not need to be done alone. All right. So, John, John says, since this problem does not include a constant, how do you find the factors P for P over Q? Well, since it doesn't include a constant, I am not aware for the rational zero test that it's going to work because you don't have a constant, right? So remember, your Q is the coefficient of your leading term, and P would be your constant. Well, in this case, my P is 0. So I cannot apply the rational zero test. And that's at least from my remembering and understanding of that. So I just say you cannot apply. Now, obviously, you could factor out an X and then find rational zeros, but I don't know if we can verify or prove that those would actually be rational zeros either, even though that would be a factor of that polynomial. I don't know if we can apply that from on there. So I would just say we can't confirm what the rational zeros are when we don't have a constant P. Now, what about if we know that there's a zero? Well, now that we know that's a zero, we can use synthetic division. And remember, if it is a zero, we know that when applying synthetic division, we are now going to get a remainder. So that's critically important. So to apply when I have a zero, so I'm going to take 2. And I'm going to put it on the outside of this box. And then I'm going to take the coefficients of each of my terms. So I'm going to have a -1, a -3, a 22, and a -24. Okay, because again, we don't have a P, right? So leave that off. All right, so if we, again, by applying synthetic division, I know my last number better be 0. If it's not, then 2 is not 0, or I made a mistake, right? So what is the synthetic division algorithm? You're going to always bring down the first one. That is going to be the freebie, right? A lot of times I always tell students, like, remember the Price is Right? Like, come on down. Like, first one, that's the winner. You get that one sticks. Then you're going to multiply on the diagonal, add on the vertical. So -1 times 2 is a -2. -3 plus -2 is a -5. -5 times 2 is a -10. 22 plus -10 is going to be a 12. 12 times 2 is going to be a +4. -24 plus positive 24 is a 0. So that is our remainder. Now, what also like confuses students a lot of times is, well, how do I find the quotient, right? And I just have a list of these 3 numbers. So if 12 is going to be my remainder, then 0 is my remainder. That means 12 is going to be my constant. This is going to be the linear or coefficient of my linear term, and this is going to be the coefficient of my quadratic. So now I know that this is a factor which can be written in the form of -x² minus a 5x plus 12. Okay, so since that is a factor, if I need to find further zeros, I can set that factor and set it equal to 0. Now, the one student was asking me, like, how do I know if something is factorable or not? And if I was going to factor this, I would divide both sides by -1. That's not going to change my solution, but let's see if this is factorable. So if I wanted to factor this, I know that the first 2 terms have to be x and x, right? And now I'm going to look into the factors. What are the factors of 12? This is stuff that I'm doing in my head. What 2 numbers multiply to give me 12? Do any of them add to give me -5, right? Because when the last number is positive, that means I need both factors to either be both positive or both negative. Well, in this case, since my middle term is negative, I'm looking for both factors both to be negative. But again, if we look at the factors of 12, 12 and 1, those add to 13. 6 and 2, that adds to 8. 3 and 4, that adds to -5. So this is not going to be factorable. Positive, yeah, that should be a negative. Yeah, thank you. That should be a negative, actually, so you're right. So now, that actually should be, now I'm looking for the difference of my factors, right? So now, since my 12, I forgot to factor both of my negative, that should be a positive. Jeez, oh man. Thank you, RF. I forgot to factor out the negative. Everything should be different sign. Okay. So when I'm looking, so now actually, since my last term is negative, I'm looking for the difference of my 2 factors to give me 5. So again, go back to your factors. 12 and 1 have a difference of 11. 6 and 2 have a difference of 4. Close, but no cigar. And then 3 and 4 have a difference of 1. So this is not going to be factorable across our rational numbers here. So what I'm going to need to do is go back to the quadratic formula. So I'm going to say, I'm just going to use this form here. So let's go do -x² minus a 5x plus 12 equals 0. And let's go and use the good old quadratic formula. So x equals a opposite of b, which is positive 5, plus or minus the square root of negative 5 squared minus a 4 times a, which is negative 1 times c. Okay, so let's see. Oh, that's all divided by 2 times a, which is 2 times a negative 1. All right, run out of space here. So negative 5 squared is a 25, and negative 4 times negative 1 is a positive 4. 4 times 12, 4, 24, 48. So that's going to be a 25 plus 48, which is going to be a 73. So x is going to equal a positive 5 plus or minus square root of 73, which I'm not aware can be broken down or further simplified, divided by a negative 2. Now, those are going to be plus or minus. That's going to be 2 zeros there. And I also have x equals a positive 2. That is going to be my other 0. So that is how you would find it. So you use synthetic division to find the other factor, and then you either break down the other factor by factoring, which we couldn't do. So therefore, I had to use the quadratic formula to go and find the other two factors. All right, next question. How do you sketch 7 pi in standard form? So to answer this question, it's important to understand a couple things. One, we need to understand what exactly is standard form. So if we have an XY axis, all right, when we start with our initial side here along the positive side of the x-axis, and we rotate counterclockwise, that is going to be what we call our positive direction. When we rotate clockwise, that is going to be our negative direction. Now, so this is a negative 7 pi. So that means we're going to go clockwise in our rotation. But we need to do 7 pi's. So we need to understand, well, what is even pi? Like, where do we get to that? So I'm going to use the positive version of this, and then we'll get to that in a second. So let me see. We'll do one more. Okay. So go back to my finger. All right. So let's do a circle. There's a horrible circle. Let's redo that. Oh, there you go. Zoom in. Come on. There you go. Yes. So let's go through this. All right. So if you have a circle, try to do a better job here. So I have a circle, right? And if you were to go ahead and take that radius, or take the radius from here, no, I need red. If you're going to take that radius from here to here, and you were to wrap that radius around the circumference of the circle, you'd get something right here, which we call 1 radian. Take it twice, take this, or sorry, let's go back. If you take that distance, the radius, right, from the center to a point, and pretend that's like a pasta noodle, nice and rigid. But then if I drop it in boiling water and then I wrap it around the circle, 1 radian would be roughly around there. 2 radians would be right there. And I did do a horrible circle, so 3 radians would be right there, right? So that's like 1 radian, 2 radian, 3 radians, or 3 radiuses wrapped around the circle. All halfway around the circle, it'd be so perfect if 3 radiuses wrapped around the circle is exactly half of the circle. But unfortunately, that's not the case. It takes 3.14159 ... radiuses wrapped around the circle to get to halfway around a circle, which is going to be our constant pi. So halfway around a circle is going to be pi. Now again, finally getting to your answer, you said you want to know what negative 7 pi is. Well, if halfway around a circle is negative pi, here would be negative 2 pi, right? So negative 2 pi. And then we know going back around again, oops. Let me move all this stuff over. There you go. So all the way around is negative 2 pi. If I go around again, that's going to be a negative 4 pi. If I go around again, this is going to be to a negative 6 pi, right? I'm just adding by 2s because all the way around the circle is 2 pi. We're going in this negative direction. And then to get to 7, I'm at negative 6 pi. To get to 7, I'm just going to go all the way over halfway around the circle. And voila, that is going to be your negative 7 pi. All right, Alina says matrices to powers when multiplying two matrices. So we have A, we have V. We need to compute. Oh, actually, you know what? I'm going to need back over. I'm going to go back over that one again. Because I didn't read that. I read that as A squared back in from on there. And so I didn't do that extra thing. So I want to compute those because I never taught. I obviously I went through matrices, but it's been a long time since going through matrices. So I want to make sure that I go through working through that through A cubed. For some reason, I only read it as A squared. All right. Can you make similar videos? So Twitch to Macori27 clips. Can you make some videos similar to this, please? And thank you. So this one says solve the inequality, says 9.5x minus 1.25 is less than 32. Which of the following graphs shows the solution? So I don't want to deal with decimals. You can deal with decimals if you want to. I just rather not. So what I'm going to do is multiply everything by 100. Now, why 100 and not 10? Well, the reason being is because here, if I multiply by 10, yeah, I won't have a decimal. But over here, I need to move it over 2 decimal points, okay? So yes, you're right. Matrices are easy. It's not really that too bad. It's just I need to go back through those numbers to work through them. And even A cubed is not something that's extremely difficult in the case. I just want to make sure I go through the process. So we're going to multiply this over. So this is 950x, and then minus 125 is less than 3,200. All right. So now I can just solve for x. So I'm going to add a 1,000 or 125. So I have a 950x is less than a 3325 or 3,325. And now I need to divide by 950. Well, I know, think about this like in rowing this. Think about this. If you're going to divide 9, I know 9, let's do multiples. I know it's going to be 3 something, not 4, because 9 times 4 is 36. And obviously this is less than 36. So if I just did 950 times 950 times 950, that's going to be 27. So that'd be 28. So that'd be 27, 28, 50, right? And then I'm looking at this, and if I was to subtract 325, that would be roughly almost 425. So it's roughly half of that, or it is half of that. 425 or 475, 375, no, 475, which is going to be half of that. So therefore, I can say x is going to be less than, let's see, that's going to be 3.5. So less than 3.5, not less than or equal to. It can't be that one, can't be that one. It's either really close to 3 or 3.5. Looks like it's going to be this last answer, D. Yashenk asked, I asked before, I apologize, but you never answered it. Well, now today is your day. I am going to answer it. So what do we do here? So which expression is equivalent to a x squared times x plus 2 times x minus 2 plus 4? Okay, so the first thing you're going to want to do here is go ahead and do x squared times x plus 2 times an x minus 2 plus 4. Okay, so first thing I'm going to do is actually multiply the x plus 2 times the x minus 2. That's a difference of 2 squares. That's going to give me a x squared minus 4. Now I'm going to do an x squared times x squared minus 4. Distribute that, and then again, that's a plus 4. So distribute that, and I'm going to get a x to the 4th minus a 4x squared plus 4. Okay, now that is not an answer. But one thing I recognize here is my first term is a square term. My last number is a square term. This is actually a perfect square trinomial. If you were to take a look at x squared minus 4x plus 4, that can be factored down into an x minus 2 quantity squared. So the only difference here is that I have raised the terms of my powers. So in this case, all I simply need to do is just raise this to a x squared minus a 2 squared. And voila, that's going to be your answer, A. Okay, how would you solve this question to find all of the zeros? So this actually is kind of going back to the one that we did at the beginning. It doesn't say how to find the zeros. So one thing you can go ahead and use is graphing technology to find a rational zero, then use synthetic division. Or if you don't have a graphing technology or you're not allowed, it doesn't look like it's factorable by grouping. And I don't see any real way for me to be able to separate these to kind of make sense for for factoring out or for factoring by grouping. So one thing we can do is use the rational zero test. So the rational zero test is plus or minus P over Q is going to give you the plausibility of your rational zeros. So that's going to equal plus or minus, you're going to take the factors of your P over the factors of your Q. So I'm going to have plus or minus, let's see, it's going to be 15, 5, 3, and 1, all over the factors of 2, which is going to be 2 and 1. So 15, 5, 3, and 1, 2, and 1. Now, one thing, these are going to be a list of your rational zeros where you can just test onto, now obviously you can write all these out, but I don't want to waste the time doing all this. So what I'm going to do is just pick some rational zeros. So the easiest rational zeros that I would start with is 1, -1, and 3 and -3, right? We just need to find something that's going to be a rational zero. I'm obviously going to start with 1 because that would be the easiest one to work with because it's a small number and it's positive. So let's go ahead and take our coefficients, a 2, 11, 2, and -15. And again, if I get a remainder here, then I know that it's a 0. So again, come on down. First one's free. 2 times 1 is 2. 11 plus 2 is a 13. 13 times 1 is 13. 2 plus 13 is a 15. 15 times 1 is a positive 15, and that is going to be a 0. So therefore, sweet, we got a remainder, constant, linear, quadratic. So this is also going to be a factor, which is a 2x squared plus a 13x plus 15. So since that's a factor, we can set it equal to 0 and see if we can factor it further. Now again, I know that to factor this, I'm going to have a 2x and an x. And then I think what two factors multiply to give me 15, add to give me 13. Since both things are positive, I know that I both need to have a positive and a positive. And then 15 factors of 15 could be 5 and 3, 15 and 1. But if I multiply 2 times 5, that's going to give me 10. And then 1 times 3 would give me 3. 10 times 3, 10 plus 3, is 13. So that would work. X plus 5 and x plus 3. Now set it factored form equal to 0. And I can apply now my zero product property. So a 2x plus 3 is equal to 0. And a x plus 5 is equal to 0. So apply the zero product property. X equals a -3/2. And x equals a -5. Whew. All right. Yeah. So anyways, going back to the matrices question, you guys had a lot. So I computed this for a squared, not AV. And so, yeah, it's not a very difficult problem. The only problem with the a squared was I got some very high numbers. And so therefore, to then go and do it again, I'm going to need a calculator. And the problem is I don't have a calculator and I don't want to waste my time using my calculator on my computer and being like nice and slow. I just don't think it's going to make a great video. So that's why I am skipping it. Because even a squared wasn't that bad. It wasn't a bad problem. It's just I had got to my higher point where I didn't need to use a calculator, but I know if I need to compute a cubed, I'm definitely gonna have some bigger values, and I don't want to waste my time or waste your time of me like doing calculations on that point. So I'll go ahead and make sure that I have my calculator next time I do it, and therefore I can run through that video for you guys. All right, cool. Well, awesome, ladies and gentlemen. So thank you so much, guys, for showing up. This was over an hour live stream. I love it. I appreciate it. Thanks so much, guys, for joining. Hopefully this video was helpful for you. And again, if you have math questions, go to brianmclogan.com/Q&A. But before I do that, let me go back into my poll. CIA's. Let me see. Oh. So get help on a specific problem. 41% of you said that is the number one. That is most likely where you guys come into my content. Well, awesome. Well, thank you guys for submitting your question into that poll. And I hope you guys have a great week. And I will plan on seeing you guys maybe next week. We'll see. I don't know. We got the Super Bowl, so we'll see how that goes. But I'll do my best. Submit those questions. Thanks so much. Have a great week. Why did I lose my thing? There you go. Bye.